System designs. When you talk about system, if you're a medical student, first thing that will come to your mind is endocrine system, digestive system, pancreatic system. Um, there are a lot of there are systems out there actually. There are systems in the human body that comes together to achieve a certain goal, right? For example, the digestive system, its goal is to make sure that food is being digested, right? And so now the process starts from the mouth and to the large intestine, right? And so those process is what makes up the digestive system. From food entering your mouth to the salivas and the enzymes that are in the salivas that help break down the food component, especially starch, and then it goes through the esophagus. Those pipelines it goes through makes up an entire system, right? And now, when you want to talk about system in our world, right? Um, you want to say the example that comes to my mind often, is, let's say, Nigerian school system, right? Nigerian school system a way is a kind of way Nigerian system operate from the primary level to the university level. And I promise you, Nigerian school system is actually a bad design. It's a bad system design. It's a very bad system design. It's not scalable. It's not maintainable. It's not its goal it have not been achieved for a while, right? And so this example actually is for me to tell you that when you talk about system, they are components. Systems are components that comes together to achieve common goal or to achieve a use case or multiple use cases, right? That's what systems are. And so when you add this design into it, design is now how you design a particular system or optimize a particular system to function at its best to achieve that specific goal, right? So how you design, how was the digestive system designed to be able to achieve its goal? So there are a lot of components that came together that created that pipeline of food moving from your mouth to your large intestine, right? Now, this is for systems that were built, that we discovered as scientists, right? Now, when it comes to the IT industry, we have what we call system designs, right? We have what we call system, and so these systems are what we create ourselves, right? These are systems that we create and design ourselves, right? And we design this system in a way that we want it to achieve the specific goal we want it to achieve without it breaking, without it actually breaking generally. Maybe breaking from load, breaking from traffic, breaking from exhaustion, breaking from fault or bad error handling. We really don't want it to break. So we are designing in a way that it will adapt, or it will be able to adapt to pressures, it will be able to adapt to changes in technology. Right? So that's the reason behind system design. Designing a system to be able to adapt to different environments. Right? Now, having established this, now I want us to build a small system design. Now in this course, right, um this is a system design series. Let me put this now there. This is a system design series. So as much as possible, subscribe to this channel if you want to understand how system works, right? If you want to understand how each component in this system works and how each component is being linked to the next component, right? And also how they communicate to each other, right? And what each component is made up of and what each component does and why they exist at the first place. Right? Subscribe to this channel because we cannot actually exhaust system design in one sitting, right? And so this will be a series. It will be a series that in this particular city, what you want to do is just to give you an overview of what system design is, a foundation, right? I call it a foundation that we build upon and decipher all the components that we mentioned and every other thing that makes system design a good system design. And so at the end of this series, you come out to become an engineer that really understand how system works, right? And so this is actually alienated from any language. It's isolated from any language. It's not language specific. What I'm trying to teach is system design as system design. And so it doesn't matter whether you're writing Rust, Go, Python, TypeScript, PHP. It doesn't really matter, right? So the goal is that at the end of the day, you use those languages as tools to bring this design to life. That's the core idea, right? Now, having put all this thing out of the way, now so let's start by actually designing a real system, right? So you want to design a system. We want to use a bank system to design, because majorly I build systems where mistakes are expensive, and so banking system is a good example, right? So okay, so um, let's give our bank a name. So this is our bank here. So let's try and give this bank a name. So which name will we give our bank? Um, let's call this Azoms. So this is the name of our bank, right? It's called Azoms, right? And so this bank we only have one operation, right? We use one operation. It will be as simple as possible to make sure we understand what this is. This bank we have one operation, right? And the operation we want to work with is very simple. So we want to have a user. Sorry, we want to have someone here, and we want to have people here. So just follow along, right? You really understand what I'm trying to do at the end of the day. So the line continues. And so we want to call this guy the cashier, right? I want to call this guy the cashier. I want to call this the cashier counter, the cashier counter. So what happens in this operation flow is very simple, right? So our operation is very simple. So customers comes to this cashier here, right? Comes to this counter here, right? To either do one of the to do one thing only, one or two things, sorry, which is to so first of all they will come to this counter, right? They will have to come to the counter, right? And then second of all, they either want to deposit or withdraw a certain amount of money, right? Then the cashier will usher them a receipt. That's an evidence that okay, that this person withdrew or deposited this money so and so date, right? And then we are done with that customer, and then the customer can now move ahead to the next, right? Or go home or do whatever else they want to do. Now this is our flow, right? So the flow is very simple. A customer will come to our bank, will come to this cashier counter, right? Now either tell the cashier that I want to withdraw money or deposit money, right? And then the cashier will give them a receipt, and they are done, and we are on our way. Now, looking at this thing like this, right? Now, when you want to design a system, any system at all, right? You want to break it down into input, process, and output, right? Right? Pay close attention. So no matter how complex what you've been told to build is, there's a basic flow. Input, what is coming in; process, what is being processed; what is the expected output. So process is just transforming the data, the input into an output, right? And so what is happening here is that so the input here is that um this customers this customer is requesting for something, right? They came to request for something. The process is this, right? That the money is being deposited or being withdrawn. then the solution, sorry, the output, not the solution, is this receipt, is the output, is a confirmation that okay, the output. Then when these things have happened, this is the done. Now, looking at this system like this, everything looks fine, right? Everything looks very, very good from the outside, right? If you have, because when you're designing a system, right, there are some things that should come to your mind, right? So what if there are a lot of questions of what if, that should come to your mind. What are the trade-offs? What if this happen? You should anticipate error. You should be proactive, right? Anticipate error ahead of time, right? So what if should actually come to your mind a lot, right? It should come to your mind a whole lot. Now, in this system, in this our simple operation, right, where customers comes, withdraw, deposit money, there are some issues that will make this our system not to function again. There are a whole lot of issues if you're looking at this thing that can really make customers not to be satisfied, that can make our bank to fold, right? And that can make our bank not to be trusted again, right? There are a whole lot of issues. And so, first of all, what we need to understand is what are these issues, right? What are these issues and how can we handle them, right? So, this is what we want to understand first. What are the issues in this system and how you can handle them? Now, the first obvious, very obvious problem here, right? The first very obvious problem here, now this can also be called the life cycle of the customer. Like this life cycle, this is what the data should look like. So this is life cycle of the data. Data comes in and is being processed, received, and they are done. This is a life cycle, right, of each customer, right? And now, the first issue now you have to notice is that the process is slow, right? That's the first. This is the first obvious issue. The process is slow. Please don't really mind my writing, my handwriting. So the process is slow. This is the first obvious issue. This is the first obvious issue that you will find that this process is very slow. And then another question now you ask is, why is this slow? Why do we think that this process is slow? These are the questions you should ask, right? What makes this thing slow? Now imagine that this cashier is attending to, it takes 10 minutes to attend to one customer, right? It takes 10 minutes per customer. Just imagine it takes 10 minutes per customer. And so that means that it will take this cashier 60 minutes to attend to 6 customers. It takes approximately 60 minutes to attend to 6 customers, right? And this is an issue because when you have, let's say, 1,000 customers here, right, you find out that is a huge issue, right, both on the customer's end and on the cashier end, right? The cashier will be exhausted and might break down, will eventually break down because the cashier is the only person handling this thing, right? And the customers will not be satisfied and will be angry because their satisfaction rate is small and the process of them being satisfied with that small satisfaction is small. And it will come a point where the cashier will now be angrily responding to these people because I'm already tired. Do you get? Now, think with me. Think with me. Now, we will now be asking, so how can we actually mitigate this issue? How can we solve this problem, right? And one of the ways you want to solve this problem is to actually train this cashier to be a little bit fast, right? So the process is slow and we want to train this. So first thing, one of the things we want to do is that, in fact, first of all, before we talk about the things we want to do, now we want to let's list the things the cashier does. So first of all, one of the things the cashier does is that the cashier actually interact with the customers to know what the customer really wants, right? So it will have to um, get the customer's request, what the customer really wants, first of all, right? And second of all, if it's either withdraw or deposit, the cashier have to count the money manually, right? The cashier has to count the money. In fact, the cashier has to count the money twice or three times to be sure that the amount is really the amount, right? Then thirdly, the cashier will have to now issue receipts, right? Now, this process takes a lot of time because sometimes the customers might not know how to communicate, right? It happens a lot. And so that's why it might take up to 10 minutes to attend to, or even more to attend to one customer. But this is on an average, right? Now, one of the things you want to do to solve this problem is that you want to train the cashier to be fast, to be fast at counting counting money, right? Counting money. That's one of the things you want to make sure that the cashier can do. This and counting money, right? And also you want to train the cashier to be fast in typing, right? The typing speed, when issuing this receipt, because you have to put in some details, right? So now let's imagine that cashier here, this cashier here, right, was able to undergo our training, right, and came out successfully and is now fast. And so the time per each customer will reduce to 5 minutes per customer, which is a drastic improvement. In fact, this improvement is huge, right? Is very, very, very huge, right? And now we have actually done a great job already, right? We've done a great job by actually improving the customer skill to each speak. Now, remember, we didn't add we've not added any resources yet, right, to this cashier, right? We've not added any resources. What we did was just to upscale its skill to its maximum level, right? That's what we did for this cashier. Now, the second issue here now that we notice in this our so the second issue we notice here in this our bank flow is that customers keep coming. So issue number two is that is the increase in customers, right? Because um we have rush hours in banks, which can be evening time, right? Evening time are mostly rush hours, right? Especially weekends on Fridays, right? They are rush hours. And so customers are coming. And so this is what actually increases the whole time spent per customer, because when more customers are coming, the cashier is being exhausted and the time required to attend the next customer will actually increase, right? So now excuse me. So this is an increase in customers, right? There are a whole lot of customers coming in, there are a whole lot of customers coming in, and we have actually increased our cashier to its peak. So our cashier is now performing at its peak level. We've trained it to perform at its peak level, right? And so what can we do to actually reduce our time a little bit? Because the more customers are coming, the more we need to be more faster, right? So what we can do is to now increase or amplify our cashier counter, right? The counter itself that the cashier is staying on, right? That's what we need to do. We have to now amplify it, right? We have to increase it. So one of the ways we can do is to increase the desk. We have to increase the desk, right? And number two is that we have to introduce um, a counting machine, right? Machine, a counting machine. See, MCN, that's what I used to represent, or MCH to represent a counting machine, right? That's what we introduce a counting machine, right? And one other thing we can do is to provide forms, right? You can provide forms for these users, for the customers, sorry, right? Instead of customers to interact with the cashier often, which can actually exhaust the cashier and also increase time, we provide form for the customers to fill. And so the customers, what they will do is just to fill this form, right? So they will fill this form. Um, Customer one, they just give this form to these customers that are in this queue. They just fill the form, fill what they want, and also it will help in communication. Right? It will help tell the cashier exactly what they want instead of coming to the counter and start speaking a lot of English and over explaining themselves. So what they do is just to take this form, submit it, and now this have actually reduced amplifying our counter have actually reduced the time from 5 minutes to 3 minutes per customer, right? And we have actually done a whole lot of improvement here, right? And now we are not facing another problem actually. The next problem we are facing is that customers are waiting, right? The third issue is that is a customers waiting time, customers, customers waiting time, customers waiting time, WT, right? So these are another issue because there are a lot of queues, customers are waiting. Now we've actually maxed out the counter and we've maxed out the cashier, right? So there is nothing else we can do for them. So at this point, what they can do is 3 minutes per per customer, right? And so there is still a lot of people coming. The queue is still much, but this is how fast they can now go, right? 3 seconds, 3 minutes per customer. And so, what can we now do since customers are waiting and they are complaining at the background? In fact, this also happen often in banks, and so we don't want it to happen in our Azoms Bank, right? We want to be more modernized and take customers' time serious, right? What we have to now do in what we have to now do in this case is to add more customers, more counters, right? We have to add another counter with a cashier, right? That's what we have to do. Um, Adding another cashier. So this is our initial cashier one, this cashier two, right? With counter two, counter one, right? Now, adding this second counter, right, will actually reduce the queue. We reduce customers waiting time, right? And so the customers, so let's say that there are 1,000 people in the queue, 1,000. So 5,000 can go here, 5,000 can go here, right? And that will reduce the waiting time of customers and improve their satisfaction, right? In fact, most of the time, what customers want is that they are seeing that the line is growing, and some also what they want is that they want to just be the person being attended to, no matter how many time is being wasted. In fact, when a customer is being attended to, they don't care whether another person is at the queue or not, right? And so is the cashiers that always worry somebody else is at the queue, just please wait behind or do these things, something like that. Now, we have solved this customers waiting problem by introducing counters, right? Another counter. You can still introduce more counters to reduce the numbers to maybe 300 per counter, right? And this is actually now making the customers to wait less, right? Now, this introducing counters also introduce another problem, right? Because initially, counter one, right? Counter one was actually doing a good job, right? Cashier one was actually doing a good job. Sorry, cashier one was actually doing a good job, and when after finish counting, he just push the information to the our bank's cabinet file, right, or to our bank's database file, right? That's what he does. Now we've introduced another cashier here, right? We've introduced another cashier here, right? Which created another problem, right? How can this cashier be able to actually sync his data to this place? Because the problem here is now that let's say that 5,000 people are here in this place, right? And 5,000 are here, right? And now these two can sync together. They cannot sync at the same. This cashier one doesn't know which customer have been attended to, right? This cashier two doesn't know which customers cashier one have attended to, and so some of these customers can come to this place, right? Let's say withdraw $2,000, right, and then also move over to this guy and also withdraw $2,000, and their account balance will still remain the same, right? Because this guy did the first transaction and this guy doesn't know about it. This cashier two doesn't know about it, and this guy still went to this place to withdraw that money. That's very, very expensive. It makes the system less trustworthy, and there can be a whole lot of things that can go wrong, right? And so if that thing happen a lot of time, people can start stealing, and our bank is actually prone to be sued to court, and we don't want it. We don't want to tarnish our image. We don't want to tarnish the image of our customers. We want our customers to keep coming and keep to keep being trusted, right? What will we do? We will now have to create a centralized database. So we are now solving the problem of that was created when we created these two counters, right? So the problem that was created when we created these two counters is that how can we now sync the activities that is going inside of these individual counters, right? Happening between these individual cashiers, right? How can we now sync it together so that they will be aware of who have actually been attended here, the balance, and who have actually been attended there and their balance, right? Which is very, very important. And so we create a centralized database, or you can still create a distributed database. The idea is that this storage device is where all the information is going to. And so if cashier one wants to attend anybody, cashier one will have to go to this our bank storage device, and check the current information of this guy, and then pull it and respond accordingly, right? And so cashier two will still do the same. And so if this customer is a criminal and wants to still go to this guy and still withdraw money, right? This guy will call here. This cashier two will go to the database, pull his current feedback, right? His current balance and what activity that they have done, right? And pull it out, and then gives this criminal that wants to come and steal another money here its money and reduce its balance. If there is no money at all in their balance, they will just tell this guy, you don't have any money again, you can just deposit if you want to, right? And that's being reliable. That's reliability, right? Now also this creating two counter also created another problem, right? And so the problem this having two different counters created for us again is that so let me just draw this here. So we have counter one, this cashier, this another cashier. um so let's call this cashier two, right? And so another problem this have created is that, let's say we have customers that want to, you know, that needs attendance, right? So these two have been created, so the line should ideally, right, be breaking down into maybe two equal parts, or broken down to the person with the lesser um, load, right? Now, but because we are human beings, right, these customers might want to go to the client, or want to go to the cashier that is friendly, that will want to listen to them. Let's say cashier one is having a bad day, right, and like she's just responding to them straightforward. There is no need of maybe interacting, right? So because of that, most of the people in the queue will now start requeuing to cashier two, right? Because cashier two is more friendly, is more calm, is more responsive. Life is not happening to cashier two at all, right? And now this will now cause we now defeat the idea of having two counters, because the idea of having two counters is to make sure that customers are not waiting, right? Now, because customers are now routing to this cashier two, this cashier one is now dormant, is not doing much work, right? And so, how can we actually make sure that this is actually they all have work that are being distributed to them equally? We have to have something like a gatekeeper here. This gatekeeper will be the guy here. What this guy does is this guy does two things, right? First of all, it will check the counters that are alive, that are responsive or they are responding. I said in our case, cashier one and cashier two are responsive, right? So what then this guy here we just um so this guy here, what this guy here will do is just to route these queues to different cashiers. So instead of these cashiers to choose where they will go, this guy here, what his job is just to route these customers to their different um, cashiers based on the load each cashier is handling. So let's say that cashier one is handling lesser load, cashier two is handling more load. This guy here will route most of the customers to cashier one, right? So cashier one might have 11, might have zero, or one customer. This one might have like 50, right? So this guy's work is to make sure that any other customer coming in will actually come to this um, cashier one here, and to make sure that it has enough work to do, right? And so let's say that this one is done, this guy looked and this guy is done, based on exhaustion, right? What it will do is just to route all the customers to this guy here, right? And still wait for this guy to recover, right? Now this is a basic flow of how system design works, right? So this is a basic flow of how system design works, right? This is the basic flow of how system design works. So this is how we design our bank called Azoms, right? In a real world, this is how it works. Now, so we have a life cycle, right? That customers comes in, they send their request to the cashier that they want to deposit or withdraw money, right? The cashier counts their money and give them receipt, and they are done. This is the complete life cycle of this our flow. Now, question is, how is this thing related to system design? How is it related to backend? Now, I will say this thing for short. So let's draw this. Let's do this is one. So this is our first cashier. So and this is also a way of me recapping. So we had one cashier before, and we have a counter, right? And then we have requests. We have customers. Sorry, not requests. We have customers. Then we now created two. Follow me, oh, follow me. Stay with me. Eh? We now created two cashiers, right? Then we created a database that to these two cashiers we share, right? We created a database that these two cashiers we share, right? And then we created a gate that will make sure that it will route these customers to the cashiers based on their load, right? This is the work of this man here, right? And so let's explain what this thing means or how it's been related to our um, system design. Now, this cashier here or the cashiers here are what we call our application code. Stay with me. These cashier here are what we call our application code. And so you can remember that first thing we did, right, is that the process was slow. First thing we did was to optimize this cashier, right, to its peak skill level, right? We optimize it by training it for it to be faster and training it for it to count money fast, fast in typing and fast in counting money, right? Now, these cashiers here are our application code. Now, what we do is that we improve, right, the quality of our code. How do we do it? We use LLD, we use LLD DSA, to improve the quality of our code. I know that a lot of people use this thing for. I'm so sorry to say this, but our interview systems is very very bad. It's just like Nigerian school system. You're putting people in a place for them to just cram something and not really understanding how does this thing really work in the real life? How does it apply to real life? And so somebody will be doing lit code and DSA, and at the end of the day, what is at the back of their mind is to pass interview. It's not lit for them to use it to do anything. And you find out that if you give this person, if they pass the interview and you give this person this thing, at the end of the day, they do not know what they are doing. And yeah, that's the system we find ourselves inside actually. Right. So what does LLD stand for? LLD just means low level design, and DSA means this data structure and algorithm. And so what does this thing look like? So when you talk about low level design, right, we are talking about how you structure your code internally, right? From boundaries to responsibilities to classes to models, right? That's what you're talking about. And so we're talking about how does how did you actually um, give responsibility to each file, right? What does each file do? Are they classified based on responsibility, or do you pack everything at once? Right. So LLD, when you actually implement LLD, your LLD is used mostly in our day-to-day coding world, right? When you talk about modularizing your code, when you talk about organizing your code, making sure that each module has one responsibility they're handling, right? You are not packing all responsibility to one model. You have your business logic, you have your provider folder, you have your business logic folder, you have your controller folder, you have your service folder, you have your routers folder, you have your database folder, right? This is how you handle your internals, right? And so when you talk about DSA, you're talking about data structure. Data structure is just how you store your code, right? How you store data, sorry. An algorithm is the processing of this data, right? And so an example that comes to my mind is the example of looping, right? So you want to get users by ID. So instead of looping through all users, right, you can use hash maps or dictionary, right? Use zeros and one to get this user. So hash map or dictionary is a DSA design, is a DSA improvement compared to looping through all users. Another one is queuing, right? You can use queue and the queue to actually queue jobs, right? Instead of using the normal process of arrays, right? So this is an example. It's just like trying to improve your code to actually handle data much more better and much more efficiently, right? And so this is when what we mean when we talk about we improve the cashier's skill level, right, to each peak, right? And so now the cashier is at this peak by training. And so we say that this cashier is our application code, and we improve our application code to each peak by this LLD and DSA, right? Then we now say, okay, this cashier have been optimized to its peak, and we cannot optimize it again. What's the next thing to optimize? And we say, okay, let's optimize the cashier counter. Right? You optimize the cashier counter by adding what is it called? By adding increasing the size of the cashier counter, and also by adding counting machine, sorry, and giving the customers form, right? And so this cashier counter actually, you should have figured that out already, is our server, right? This is our server, and what we did here was just to optimize our server to upgrade it to its maximum level, our single server to its maximum level, right? That's what we did. And so what this first one, this cashier does was just to increase our processing time, right? Optimizing our code was just to increase our processing time. This cashier server, right? What we did was just to make sure that customers are being attended to, right? Then we now introduce different. Now, what this is being called, right? What this is being called, upgrading this single server, what is being called is vertical scaling, right? We call it vertical scaling, and it is what it is, right? You're scaling vertically. You're upgrading the already existing components inside your server, right? That's what vertical scaling means, right? You're upgrading the already existing components inside your server, right? So that's what vertical scaling means. And so servers are um, um, machines that sit in an IP address. That's what it is. So, but that's what we say that we will look into these things individually, right? So we want to have an overview of what system design is. And so now we introduce different servers, which is different counters to this our application code, right? And this is what we call horizontal scaling. Horizontal scaling. So this is where distributed system comes into play. This is called horizontal scaling. And now, then we also introduce a database. This database we introduced was actually centralized. Right, you can have decentralized database, right? But at the end of the day, a place where you can store and retrieve data. Right, that's what this thing is. A place where you can store and retrieve data is called database, right? And then we also wanted to make sure that, and also before I forget, actually, these customers are called requests. Requests coming into our system, right? Now, this gateman here making sure that it routes these users to different servers and making sure it monitors which server is alive, and route the customers or the requests coming in based on the servers that are alive is called load balancer or load balancers actually. What they do is just to balance loads across different servers. That's what they do, right? And so they make sure that the requests coming in are being routed based on the work each server is handling, right? And so now also we also have what we call message queues, we have caching, we have a whole lot that actually makes up this. And so in the coming videos, what we will do is to take this component, each of and every one of them one by one, and explain what they are, right? Explain what they are, explain what they do, explain what they don't do, explain how it's being linked to our core system, right? And so this overview also is enough for you to actually build your software. It's enough for you to maybe hire somebody because you have an overview of what you should do. It's enough for you to hire somebody and just tell the person, if I want you to build this system, and you have this sketchy architectural design in mind while hiring them. And also you can use this basic sketch and maybe do your interview if you want to, right? Yeah, so this is it. So look forward actually for my videos. This is a new series we started, right? Subscribe and also share to people that will want this, and like, and so that the algorithm will show this video to much more people, right? And stick around for our next video, right? And this is a series, so try as much as possible to subscribe so that each time we drop a topic under this series, you get notified. See you guys in my next video. Peace out.